So let's do it, guys. Today we will talk about modules and packages in Python, and basically in my mind it's a continuation of the main idea that we have in programming. It's about that we want to write our code in an efficient way, and also then to be able to reuse it and do not implement the same things over and over again. Today we will try to pack our functions that we implemented before, or we will implement some other new functions as well into modules or packages, and then we will be able to reuse them in different projects. And module in Python simply just as you can think about it as a separate file, and inside of this file we can specify different functions, different constants, values. Later on we will see that we can implement some classes, and we can store all of this inside of the files. And basically each file, it's a module in Python. Packages, it's a little bit more complicated thing. It's combination of different modules, packages, of different modules that have more flexibility. Let's create a new folder. I will call it just week 007. And now let's create a file. I'll call it math_module.py. And guys, let's try to not check the website for a moment. And I want you to implement, just like to warm up in the beginning of the lesson. I want you to implement the function which is called GCD. Basically, it stands for greatest common divisor. It takes two arguments, and then we should return something here. So also I want to say that in Python, if you, for example, don't want to specify the body of the function yet, you can just write pass. But the idea is to implement the GCD. I will fetch the wiki page about greatest common divisor, and let's try to implement it so that you will try to implement it yourself. Basically, the idea is that we want to find for two numbers. For example, let's say that we have input 48 and 18. We want to find the greatest common divisor. In this case, it's 6. And for us, we can utilize the Euclidean algorithm. The idea is that there is a feature of the GCD that it can be written in the following way. Let me just find it. There are so many properties. Probably it's better to check it in the Euclidean algorithm. I don't know, guys, if you already have done it on the discrete math or something like that, just let me know. But the idea is that the idea is that if you have two numbers, for example, A and B, and we want to find the GCD for them, we can do the following thing. We can represent, let's say, just for simplicity, that A is greater or equal than B. Let's assume that A is greater or equal to B. In this case, so A and B, it's like some integer numbers. We can represent A as a B multiplied by Q plus R0. Let's write Q1, R0. So we can represent it, right? Basically, it's Q1, it's some integer number. Q1 integer and R0 integer. And then, so what we can do next, we can represent B as a R0 multiplied by Q2 plus R1. So it's like some math. I hope that you follow the idea. Let's say that we have as input let's say like 12 and 8. This is our input for GCD, and we want to identify the greatest common divisor. So in this case, we can represent 12 is 8 multiplied by 1 plus 4. As you can see, so there is a feature that R0 should be less, probably less, or maybe less or equal than B. So it's like basically a reminder after the division. Okay, so and we want to implement GCD. If you have any questions, guys, just like in terms of the some mathematical properties, just let me know. Otherwise, you have let's say 10 minutes to resolve the task. And yeah, let's try to not just find it in internet. Just try to understand the idea. So basically, we have some recurrent expression, which is b multiplied by q1 plus r0, then b is equal to r0 multiplied by q2 plus r1, and at some moment you will find out that at some step, so let's write one more time. So here we have r0 is equal to r1 multiplied by q3 plus r2. At some moment you will have that your GCD is AB is equal to BR0 equal to R1, R0, R1, and so on. And at some moment you'll find out that you have, for example, Rn0, this is Rn. Or also, yeah, so you should at some moment end up with something like that, I believe. Or maybe Rn, Rn. And then it's also Rn. So okay, you have, let's say, 8 minutes. Then I will ask you guys in case if you have some ideas. Yeah, and just let's try to, in case if you even didn't solve, please don't be shy. Just let's discuss your ideas that you have. And then maybe we will find out how to shape the ideas into some solution. So, okay.
Yep,
You are here, right? So, do you have any ideas?
Here.
Yeah, I'm happy to hear you. I'm happy to hear you. So, do you have any ideas about what to do?
I'm still thinking about the answer.
Okay, but anyway, maybe some like just some ideas.
I'm still thinking at the task because algorithms is not my strong ability.
Yeah, no worries, no worries.
I know that this algorithm is simple. It is studied many times and was forgotten around many times.
Yeah, I see. But for me, it's more about not just like as a solution. So we got like some, for example, solution from Syrnik. I don't know who is that, but there is some.
It's me.
Okay. So so yeah, and could you just like go over it, and I'll just give me a second. I'll just copy and paste it that everyone could see it. So basically, this is the definition, right? That you have, right? Could you just explain what is happening here, and then we will check if it works with some inputs. Olga, can you tell us, please? Don't be shy. Don't worry. Don't worry. We are like your team. We're gonna support you. We will not do anything bad.
It's simple pipeline for Euclid algorithm, and until one of the number becomes 0, replace the pair, and when one number is 0, then is a GCD.
So okay, yeah, as you said, so basically you have here some condition, right? While b is not equal to 0, and I assume that this is something that addresses the last statement, right? So basically in the Euclidean algorithm we know that at some moment, so there is a proof for that at some moment we should reach to the point where we have a reminder from the previous step, and we cannot divide number with any reminder in the end. So basically this is the idea. If we cannot divide the number with reminder, that means that we can like fully divide one number by another, and that means that this number is a divisor. And so as I got it, so here we are trying to check it. If b is equal to 0, then we will just return a, which is a correct option. If we have, for example, a and 0 as the input, then GCD is a, because a can be divided by a without reminder, and 0 can be divided by a without reminder. Then inside of the while loop, we do the following. So we reassign a and b values in the following way. So we see here that the first input is a and b, and then you're saying, okay, now I want to replace a with b and replace b with r0. And in your case, r0 it's like a reminder of a divided by b, which we can calculate by using the modulo operator. And we will do it some amount of iterations. Basically, we will replace first a and b with b r0, then we will replace b and r0 with r0 r1, and so on until we reach the moment when b will be 0. And then we will return a, which is a left operand, or left part in this expression. Let's just check it. I think that it should be fine, right, guys? Should be fine. Yeah, let's check it. And then we will see like some other solution which uses the recursive function that was provided to us by Dastan. Yeah, respect. And let's just check it. So print GCD of, and let's check, for example, 12 and 8. Then GCD for some numbers which are like, I don't know how it's in English, but probably mutually prime, or I don't know. Let's put, for example, 12 and 13. And let's check, for example, that it works with 8, 10. That if we shuffle a little bit, print GCD of 8, 1. And let's check, will it work with, for example, the negative numbers, let's say 12 and minus 8, something like that. So usually when we work with, let's say, data analysis or like bioinformatics, it's better to try to think about different test cases. So right now we are trying to test our solution against different input options. And it's usually better to provide many different options. So let's run it, and as you can see, here we have 12 and 8. The result is 4. So 12 can be divided by 4, 8 can be divided by 4, and there is no any greater divisor that can be identified here. So basically, for example, if it's 6, 12 can be divided by 6, but 8 cannot be divided by 6 without reminder. Then for 12, 13, these numbers we supposed to have Oh yeah, okay, coprime. So yeah, we have in this case, for example, coprime numbers 12 and 13, and the result is 1, which is a true. For 0, 8 we have 8 because both numbers can be divided. For 0, 1 we have 1, and here we have, for example, minus 4. We can adjust a little bit the solution here, that let's say that we take as input any numbers, and simply we can do, for example, a and b is apps of a and apps of b. And in this case we will get 4, which is more kind of natural way that let's think about that is we have that our greatest common divisor usually some positive integer number. Okay, and now let's check one more solution that we got. It's this one, so GCD swag a and b, and here we have like one line, but basically it performs the same thing. So as you can see, we have if conditional statement here, we check if b is equal to 0, very similar to the one that we have here, and then if b is equal to 0, we will return a, basically by the use of the ternary operator. And if it's not, if b is not 0, then we will use the recursive function call. We will call one more time the function, and we will replace a and b by b, a, and remainder. So the remainder can be calculated as a modulo b. And then we will just like do the same. So in this case, we have while loop inside of our GCD function. In this case, this is a recursive function that implemented here. Okay. Nice. Let's now, I will just remove all this part, and now let's implement 2 more functions. With this one, I think that we can do it probably very fast altogether. So we want to return the absolute value of the a, but let's assume that we don't have apps function, which is a built-in. So what should be written here? So we want to return the absolute value of a given number. So if you feel yourself brave enough, then just ideas are welcome. Let me try. So Stepan, are you here? Yeah. So
yes, I'm here.
Yeah. Do you have any ideas about what can we do here? We want to identify absolute value. So for example, if it's -3, we want to return 3. If it's 3, we will return 3.
Let me think.
Yeah.
Maybe we can take square and not square. We can multiple this number on this number, and then we can take a square.
Okay, I got it. So you want to multiply the value by itself and then find the square root.
Yeah.
So something like that.
Yeah.
Okay, let's check it. Interesting idea. So let's check absolute value with, for example, -3, and then print absolute value with 4. So okay, it works. We just convert it to the float, but I think it's fine. Yeah. Kind of original idea. Okay, guys, who have any other option? How it can be done? Pavel, are you here?
Yes, I had the same idea as Stepan.
Wow, the same. Guys, you're like very artistic persons. Okay, Ilya, do you have any ideas? How can we do it also?
No, unfortunately not yet.
So let's try to recall what, for example, here we want like to check. We want to check. Don't look to the Telegram channel now. Just try to think. So what? Oh yeah, thank you. Yeah. So what kind of syntaxes we have in Python? So here we want to check something, right? And what can we use? In Python there are some things which we can use in case if we want like to branch our code into two different states. So we want to control flow somehow. What kind of options we have? Do you remember? So for example, I'll try to go over a little bit. So for example, do you remember we had like loops, right? For example, for loop, while loop. Also, we had some other like constructions in Python, like syntaxes that allowed us, for example, to check. Let's say that we want like to check something. What we usually used.
We use if statements.
Yeah, we used if statement. So when we can use if statement here, right? So I can like write if a and then put something. So if a, for example, guys, help me, please.
Is less than 0.
If a is less than 0, we will return minus a, right? And otherwise, we will return just a, because then it's like greater or equal than 0. So let's just run it, and now it works. And in this case, for example, if you care about the type of the object, we will preserve it. I mean, in some sense. So here we have 4.2 is 4, and let's just check out the previous one. So here we return a multiplied by 8, 0.5. So it also works, but I believe at some moment you can get a little bit of the mismatch because of the operations with float numbers, let's say. So, and maybe in this case it's better to just check the conditional statement, and I believe that this option is like less I mean, like it requires less operations in terms of the like a computer to perform, but both of them work pretty fine. So okay, we implemented the absolute value. Now let's also implement the function factorial, or like x, n, I don't know. Let's put n. So factorial of n, and we want to implement it. And as you remember, factorial of n is equal to n multiplied by n minus 1 multiplied by n minus 2 up to 2 multiplied by 1. So when we want to calculate factorial. Guys, you have 5 minutes, and then we will discuss it. Okay, guys, ideas. So, Olga, are you here still? Can you share some ideas that you have?
Yeah, I share one.
Okay, we got one. Yeah. Let's just put it down. We got one. This is a factorial, and we check. So basically, this is a recursive function implementation, and we check as usual. So in recursive functions, there are like, in my mind, two like main components. It's something like as a stop condition when we should like stop. And in this case, so we check if n is equal to 0 or n is equal to 1. So when we got again from Syrnik, another one. So if n is less than 0, then we return none. Nice. And then, so result is equal to 1. And for I in range, basically this is with a for loop. Let's take a look on both of them. So I will start with the first one. Here we have like some conditions that we check. If n is equal to 0 or n is equal to 1, we return 1. Or n. But basically, so yeah, Stepan, here we should return 1 because I remember, like, by definition, factorial of 0 is supposed to be 1, if I remember. But maybe I remember it's incorrectly, but I think it's something tricky.
I'll check it now.
Yeah. Then otherwise, so it's like return n multiplied by factorial of n minus 1. Basically, this is a part which resembles this part. So n multiplied by n minus 1. We check n minus 1 if it's like 1, or if it becomes 1, we will return 1 and multiply this like chain of all results. Otherwise, let's check it. Let's print factorial of 10. And it's like 362. Let's double check. So there is a website which I used in when I was a little bit younger. So let's put 10 factorial. And bam, we got exactly the same solution. So we did it right, because I don't know what about you, but I believe to this thing. So, and yeah, as you can see, somehow by...
Yeah. It was missed.
Yeah, no worries. I mean, like, it's tricky part, because...
The factorial of 0 is 1, yes.
Yeah, just like to double check. And in this case, we adjusted it, we return 1 here. And yeah, then there is another implementation. Just check it. Let's check it. Copy, select it. So, and here we have another one. Oops. Oh my god. So okay, I'll just remove this part for now, and let's run it. So it gives the same result. Let's check it with 0, works. And let's check something big, 100. So when we got this result, and 100 in... Oh no, I don't want. Yeah, so 100. So when it's like 9-3, so I believe the same. Yeah, guys. So, oh, we got one more. Oof, this is impressive. Def terrible factorial. Okay. I will not copy paste it. Sorry, but guys, you can enjoy the you can enjoy it in the Telegram channel. Yeah. Basically, that's it about the functions. And this is a module. Maybe you already forgot, but we are trying to implement the module. Let's put some constants here. So here are our two constants, e and pi. And now we want to save and exit the file. So this is the current structure of our folder. We are inside of the folder week007, and now we have one file which is called math module that we just created. So as you can see, this is what this file contains. And now let's create a new file. We will call it, for example, main.py, or you can call it in any other way. And inside of this file now, when we are like in the same folder, we can write import math module. And now we can, for example, specify two variables, let's say a and b. And now we can use the functions that we implement. So as you can see, I put the name of the module that we have, math module. I put the dot. And then my editor suggests me that there are some attributes or like some objects that I can utilize from this module. And in our case, let's check, for example, GCD. Let's use GCD swag. We will just add some nice style here, and we will provide a and b. Then we can, in the same way, print math module factorial of A. And let's, for example, also get the access to the pi constant that we implemented. And now when I run it, as you can see, it works. Basically, we have the possibility or like option to get the access to the functions or like objects, variables that we implemented in the module. Yeah, also there are some interesting things about that you can, for example, rename the way how you import the module. Let's say that this one is like super long and we want to make it shorter. Then we can just replace it with import math module and get a short option for it. Let's say like as mm. And then we just need to replace all these names by mm, since we assigned a new tag or a new name for the module, and everything works perfectly. I'll just show you some other examples. Here, for example, we can import just specific function to our main file. In this case, we have like math module and we import only GCD. Why it can be important? Because sometimes the module or the package could be like super large and it can like add a lot of code to your program that you don't need in general. And in this case, you can just import particular parts of it. And in this case, we import the greatest common divisor, we run it. And as you can see, if we import something from the module using this syntax, we don't need to put in front of it the name of the module with the dot. Also, you can import everything from the module by using the wildcard. So here we use star, and then we will import everything that was in the module. Also, you can import particular function and assign a short tag for the name of the function or for the object. In this case, we from the math module, we import factorial as f, and then we can print factorial of 10. And you can see, so this is the result, everything works. And now, so I want to tell you about the particular thing which is called name. And here is an example. So if we have Python program.py, by default, when we run some file with the interpreter of Python, in this case, this program will get the name, this like attribute by default, and we can even access it inside of the of our file. Let's call that we have our file. Let's call it in the same way, program.py. And inside of this file, we will just print the name. As you can see, so this is a variable and it's like a default built-in in Python. And when I execute the program, you can see that the name for this like run, I called Python interpreter with program.py. And in this game, the name that was assigned to this file is main. But in case if we import something, so you can see that if we import the module, this module name will be different. So the name for the module that was imported will be assigned as the file name of this module. So in here I'm just trying to explain how it works. In this case we have interpreter Python and we call it with the program.py. And as I said, by default, the main file that we executed with the interpreter will get the name which is equal to main. So we will assign main to the variable double underscore name double underscore. And then in case if we have some imports inside of our file, so let's say that we import module 1, module 2, and this is the name of the file, module 1 py, that is stored in the same folder. The name for this module will be assigned as the module 1 and the module 2. Is it guys clear? So if it's not, then please just like let me know. Really, guys. So I don't know. I want like to stop for a moment, if be honest, and just ask you. So it seems that some people are like not, I don't know, maybe not brave enough to interact or like just like to share the ideas. And I don't know. So there are like two options in my mind. So one, it's like that you in general don't like Python and you're like, okay, I'm bored. I have to go to these lessons, listen all of this crap all days. But another one that you just like shy, you're afraid to ask questions. And if it's like the second one, please don't be worried. Really, I mean, I'm here. I'm on your side. I'm not trying to, you know, like bully you or something like that. I'm just trying to teach you something that I know a little bit that you would be able to use in your life. And in case if you have any questions or like if you have some struggles, please text me. There is a dedicated topic in the Python section that you can use, you can write there. And I believe that, for example, some people will help you even if I cannot. So, I mean, like the same people from your class. So, yeah, just wanted to say it like explicitly that in my mind, we should not be afraid of, I don't know, asking questions, especially when we are like learning something. This is the main purpose.
So may I ask one question?
Yeah.
Can we say that this function tell us where we are, what file,
So in some way we can
where we are?
yeah, in some way we can use it as a to understand in which file we are. So this is a example I just want to show you. So let's go back to the file that we implemented before, which is a math module, right? So this is our file. We implemented some things here. And now let's say that we have some statements like a is equal to 10, b is equal to 5, and then we print GCD of a and b. So now if I go out of the file and I execute it, so I see the result, right? Because we added the statement print GCD of a and b. Now we remember that we have main.py, right? Let's open the main.py and I will comment all print statements here. So our program now should not print anything. This one, main.py, right? Let's just execute it and we can see that we got the result 5. And we got result of 5 because when we import the module, so we imported this module which was math module, and since there are some print statements or like something that is like outputted to the standard output, we will see it inside of our main program. But sometimes we don't want to have such behavior. And in this case, we can use the name variable to check it. And so this is an example how we can tweak it. Let's go back to the math module that we had. Let's go to the bottom part. And now we just want to check if name is equal to the main, then we want to execute these lines. So let's save this file. And now, for example, if I execute the math module.py, as I did before, we got the result. It's 5. But now we remember that we imported this module inside of the main.py. And as you can see, before we got the same result 5 because everything was imported and everything was executed. But now if I do the same, if I run main.py, you can see that I don't have any result now as the output. It happens because we check the name of the module and we like execute this part only if this file was called as a main source, as a main file. But if it was imported, we will not execute this part. So and basically, yeah, we can use the name in a way to understand, for example, that file was executed as a main one, or in case if it was imported, we will see that it's like it has some name. Okay, this is about modules, and basically you can put a lot of different files inside of your folder structure and and use them. Now let's say that we have something like that. So this is our structure, right? We have main.py, math module, program, as you can see. So there is some folder was created by default by Python, which is like PyCache, and this is when we import something. So Python by default creates this folder. We will not focus on it very deeply. I just want to create a new folder. Let's call it like, I don't know, something. And I will go inside of this. So yeah, again, this is our structure. Now I went inside of the something folder, and now I want to create a new file here. So like let's create a file. I will call it program.py. And now if I write the same thing, import math module, print hello world, just to get some output. You can see, so right away my editor is saying that math module is not accessed. So let's go out, let's try to run the program, and we got the module not found error. Basically this is a problem because our main file located in some other like place, and we don't have by default the access to the module that we created. Basically it's a file, and in case if we specify the path to the file, we can access it. But sometimes we want just like to use the name of the module or like of the package and import it to our program. Because for example, if we have some built-in modules, let's just, I will comment this part. And let's say that we import some built-in module that by default comes with Python, which is a math. Now if I execute the program, everything works because Python knows that, so this math stored somewhere in particular place and we can use it. Now we will build our own package, and it will allow us to use our package module in any place on the computer if this package was installed. For this I will use a package manager which is called Poetry. I believe that you can open the link, go here, and then check how to install it on your machine. So for example, if you are using Bash, no, it's like other part. So yeah, in the beginning, so here you have the installation. You can install Poetry by using, for example, this script. It should work pretty fine in my mind in Linux, Mac OS, or Windows WSL. If you are using Windows PowerShell, you can use this option. If you are using pipx, which is probably some package manager on top of it, you can install it by using pipx install Poetry. I usually use this part, as you can see. So you just download the script, and then you just execute it to install the Poetry. Yeah, so, and when we have the Poetry installed, I hope that you can for now just go over with me in the way that you just watch, and later on you can, for example, try to do the same things yourself. Let's just try to create our new package. So I will just copy and paste the command, which is Poetry new package demo. And now, as you can see, we created a folder inside of this like something folder, which is called package demo. I will go inside of it. And then if I check the tree, you can see that by default we got readme file, package demo init.py, pyproject.toml, and tests. We can check each file individually. So in readme we don't have anything. That's up to us to fill this file. Then we can check pyproject.toml. This is a configuration file. And as you can see, here we have the name of the package, which is package demo, the version of it. You can put some description. here we have the author of the package. In my case, it's like it put the information that specified in config of the poetry by default. And then also there is a dependencies for our package. And now what we want to do, we just want to create a new file which called math module inside of the package demo folder. So one more time, this is our structure. Let's open it in the editor. Yeah, and now I just want inside of the package demo create a new file. I'll call it mathmodule.py. So I created it, I want to open it. So now I'm inside of the package demo mathmodule.py. I'll just copy paste all functions that we've implemented before. Let's save the file, and I'll save it, and I'll exit the file, and I'll exit the editor as well. So now if I check it, now we have math module inside of the package demo, and now we can build our package. So we will build it. Let's use it. So as you can see, we built the package. Now we have like a new folder which is called dist. Let's check again that we have dist, and now we have you can think about it as an app, compressed app, and this is a package that we can install now using the pip. Pip, it's like a built-in, like in Python manager, package manager, which support us installation of the packages. Python install package, you can think that this is a shorthand for this. And we can install it. So as you can see, I am using this command, like pip install dist package demo tar. And now you can see that we installed our package. Probably I supposed to do it a little bit in different way, but it works pretty fine. And now the idea that I wanted to show you. So we built it our own package, we installed it using the pip. And now let's say that I go outside and I go to another like folder. In my case, I go to my home dir and then temp. And now in case if I create a new file, let's call it nvim.py. Now, as you can see, I'm like completely outside. I'm in another folder. And before, when I tried to import the math module, I got the problem, right? And now let's just check it. So I don't know, will it work? Okay, so probably I need to why it worked in this way. Yeah, sorry guys, some problems appeared. Okay, so again, if I install it, successfully installed, and then python main.py. So let me try, I don't know, maybe by default poetry creates a new environment. I'm not sure. Let's I'll create, let's try to do it in this way. So pip install, teaching week, okay, Python week 007, something, package demo, dist, and then there is a tar. And now if I implement Python main, still okay. I'll figure out why it's happening in this way, guys. But so my assumption that there is some problem with that it makes a new environment. I don't know. Okay, guys. So I think that the problem is not about, so everything works correctly. So everything works correctly. So the problem is that I'm like a little bit dumb, right? In our case, the package called in different way. Let's go to main.py. So we installed it, but package called import package demo. It's called package demo, and then we have math module inside of the math module. Yeah, I completely forgot about that. So yeah, we have SMM. And now if I run the program, everything works. And now even so, I am still outside. I'm like in another folder. Now I can, let's say, print GCD of 12 and 8. And you can see now everything works. So yeah, I completely forgot that the package called not math module, but it's called, we specified the name, and name was inside of the, so if I go back, right, this is a pipe project, so it's a configuration, and our package called package demo, I mean like with underscore. And we need to import this package, and inside of this package we have a lot of different, we can specify a lot of different modules. And we specify just one, which called math module. And it's like a small part of the whole package, and you can add a lot of more modules inside of it. And then if you want to, just like for you, in case if you want like to get skills in it, just go over the documentation of the poetry, and then basically you can upload this folder that we have right now. So you can upload this folder, I believe even without dist or maybe with dist, to the GitHub. And in this case, you'll be able to install your package on any other machine by using pip install, and I think git plus, and just put the URL to your repository, and it will install the package. So I'll probably just show you that I did at some moment like a package in the same way. I used the poetry. Let me just show you. So yeah, here, for example, I created a package for the image processing analysis, and you can see, so you can install it by using the pip install git plus and specify the URL. And then there are, so if you go to the image processing py, in our case, we had just math module.py. Here I created different modules. For example, image processing, I called it IP. Then there is, for example, the method which identifies the depth of field. Then there are some methods for image analysis that I need to use usually. And I just stored everything in this way. And now on any machine that I have, I can install this package using the GitHub, and it's a very convenient way. And as you can see, so I shared it with a friend of mine, and he at some moment even fixed my errors that I had. And now, so it's very nice that he can use it, I can use it, and everyone can use it. Yeah, but this is the idea that now you able to build your own packages in Python by using the poetry. Yeah. So, to be honest, guys, at some moment I was thinking, so do you watch some Twitch streams? Anyone? Okay. I will make coming out. So I watch sometimes, and so there is a point that some people of them, they use so you basically can use for example smart bands that you have, like smart watches, and you can display the heart rate on the screen. So I can, for example, put my heart rate in the corner, and then you would see, for example, how my heart rate is going up when I'm making some mistakes. In the case when I forgot that I should import not math module but package demo, my heart rate is going up. I'm super stressed, But anyway, guys, I'm here and we are here and we are like doing, we are continuing, we are like, you know, it's not about what happened. It's about did you make a comeback or not. So I hope that all of you will make a comeback in any situation. Let me just check what rest is inside of the. Yeah, I don't know. So Dastan, you mentioned some UV. Is it like also like a package manager that allow you to install and create packages?
Yes, it's a little bit less verbose and less prone to errors. It got popular in the last couple of years.
Okay, I see. Yeah, I just heard about poetry, and to be honest, I think it's like pretty simple. In my case, I just like made a mistake, but beside that, works pretty fine. And then you can add, for example, some dependencies in it in case if you need like some other modules or not modules, some packages that were developed by other people. It's very easy to handle. Now let's just briefly finish the lesson by going over some built-in packages that in my mind can be useful to use in Python. So here I just provided example of decimal, math. Maybe I can make it a little bit bigger. Decimal, math, OS, sys, itertools, datetime. So these modules, they by default implemented in Python and you can use them right away. So here we have from decimal, we import particular function or like object which called decimal, and then we can perform precise arithmetic with decimal values. In this case, let's say that we have decimal 0.1 and we sum it up 3 times and we got the result 0.3. Because as you can see, in case if we use just float numbers, we will get like a float calculation. Float arithmetic tend to have some discrepancies just in the way how the float numbers stored. In this case, it's other way that you can use decimal object and calculate some like be more precise. Yeah, so here we calculate the compound interest. Let's say that we have rates per year 0. So it's like basically example that you can calculate the income that you would make in case if you deposit some money to the bank account. As you can see, before it was 0.15, but nowadays, right, guys, in Russia, how large it is? Who knows? Who is like in an investment like field? Who knows all this like stock market, like crypto? No? Okay, but basically the idea is that if you, for example, let's say that you have 1 million rubles right now, right? And in Russia, I believe that right now the compound interest so the interest rate is around like maybe 20%. And in case if you can get it, let's say for 20 years, in this case it's okay, 0.15. You can deposit it and then you will make money out of it. And let's check how many money we will get back in case if you put 1 million rubles right now to the deposit account. So, and as you can see, so you will get back 16 million back, which is not bad, right? For 20 years. Yeah, and this is just as a small example of compound interest. Yeah. I mean, there are definitely some other things that you should take into account. It's not advice, right? So I'm not giving advices about that because there is inflation, there is like some other things can happen. For example, ruble can be strong compared to US dollar, but then one day you are like, okay, it's like 2 times less or like 3 times less. There is a math module, yeah, and you can basically go to each of them. You can open the link to the decimal, and there are like a lot of different functionality that provided by these packages. I just showed some example. Then there is a math module. You can calculate the square root, power. Basically, power you can calculate without using math power. You can just write 2 and then use 2 stars, or I don't know, star operator, or like this like wildcard. Yeah, you can calculate ceiling and floor functions. This one is very interesting. So this one help you to work with operating system. Basically, you can, for example, list directories by given path. You can check that something exists. If the given path exists, you can create folders, you can rename folders, you can remove file, you can remove directories, you can remove directories and recursively. Then you can create a new paths. Yeah, basically there is a point that, for example, the separator between parts of the path can be different depending on the operating system. And then in case if you use OSPay and join, usually it should work fine. In this case, maybe it's better to adjust it. But anyway, yeah, briefly want to tell you that there is a sys, and in this case, I am just showing that you can use it to get the command line arguments from the outside of the program. Let's just check it how it works, because in this case, otherwise it's not very. So we are right now inside of the week 007. I'll create a new file. I'll call it sysexample.py, and let's just put the content that I copied. So here we have import sys, and then we can access command line arguments by using the script name stored inside of the sysargv list. So let's print it. Oops. In script name, not script name, so command line arguments stored in sysargv. And then we can just print them, sysargv. Then we get the first element of sysargv, and then we get the everything from the first one. And then there is a script name, command line arguments. Let's just save the file and I exit it. Now if I run this, so sysexample.py, now I can provide some extra arguments to my program. Let's say 100, 1000, hello, and then like hello world. And as you can see, so sysargv stores the script name. Basically everything is a string. It stores the script name, then it stores the first argument that we provided, the second one, the hello, this one, and then also hello world. Everything stored as the strings, but this is a very nice that you can provide some arguments to your program from the point when you run the program, your program. There is a iter tools. You can use it, for example, in case if you need to generate permutations. Let's just check the example. Iter tools example.py, and I want to from iter tools import permutations. Yeah, and let's say that our elements are the ACGT. And we want to generate a random DNA string. So DNA is equal permutations. Then we need to provide the elements that we have, elements. And then, for example, I want to create a 10. Print DNA. Okay, I need to convert it, for example, to the list. Okay. Yeah, I see the point. So we need to go to the iter tools and check what are the arguments of the function permutation. And then okay, so this one is like just can generate indeed all permutations, but the size cannot be larger than the given list of elements. And because of that, so I can just create all possible, for example, permutations of these elements ACGT. Let's just adjust it. So DNA is join element for LM in DNA. So yeah, we can, for example, create all possible permutations. Not a random string, but all possible options. In case if you want like to create it and then, for example, check something. Because in your case, the input elements, you can play around and then you will find out something if you need it. Okay, so it's about iter tools. Yeah, you can, for example, create a Cartesian product by using product. In this case, there are combinations also. You can create all combinations. And in general, so you can use it in case of the for example, bioinformatics. I'll just try to make a simple example. Let's say that you have let's try to do it briefly, and then we will, or maybe I'll just show you the example. So yeah, guys, please take a look on the datetime and on third-party packages yourself. I just want to show you one interesting thing about the permutations. And in general, so permutations is like very important because there are, for example, permutation tests inside of the statistical analysis, and you can use them in some particular cases of bioinformatics. And so it's like permutations alpaca probably example. So I think this is a very interesting explanation about permutation test, and this is an example where you can use, for example, permutations. So let's say that you have some group of the alpacas, and then you want to check, you have treatment control in bioinformatics, right? And now you have two groups, treatment control. And then you measured some response value. In your case, let's say that you added some supplement to the food to your alpacas or like llamas, and then you want to measure whether the weight of the one group is larger significantly than the another one. And you can calculate it that, for example, you added some supplement to the food, you got the value. You calculated the average value for the left group, and this is a 1.5 something. And now you want to check whether it was random or not. And in this case, you can create a permutation. So you see, we got some permutation. This was our like a universe. Then we got our first permutation and we calculated again the value. So in this case, it's like less than our one, right? But we want to assess the statistical significance. And in this case, the thing that you need to do, you just need to create a lot of permutations of the original universe that you had, and you will get the distribution. So now we built the null model. It's called the null model. And now we can calculate the p-value. And this is simply just the ratio of those values which are like greater or equal to the one that we observed in the beginning for the real data that we had. And we can just get this ratio divided by the full size, and we will calculate the p-value. So in our case, it's like 0.05. And you can say that if you have a threshold of 0.1, then your result, your supplement that you added to the food, shows the statistically significant higher average weight by using the permutation test. So I'll share the link with you guys in case if you are interested about it. I think it's a very nice visualization and explanation of the permutation test, and you can, for example, even use it in case if you compare two values of expression for the gene. Let's say that you have gene expression value for group A, for group B, and no one stops you to use the permutation test. You can measure it. The problem is that in case if you have like 1,000 of them, as usually we have like, let's say 10,000 genes in the RNA-seq data, we will face with the problem of the power of our test, that after the adjustment for multiple hypothesis testing, we will not see a lot of significant results. Because of that, people build up another tests which take into account the distributions of the gene expression values. Also, it takes into account the dispersion value for all genes, and because of that, it helps you to identify statistically significant genes. But this one is unparameterized. Basically, so here we don't have any assumption about the distributions of the data that we had. So that's it for today, guys. If you have any questions, then again, feel free to ask them. And next lesson, I will try to do it fun. I don't know. I mean, we will just chill, relax. So yeah, say to everyone so that if they're afraid that I will ask someone questions, I will not. They can stop by. Yeah. Also, I think that we will have a quiz one more time next time. So yeah, guys, that's it. We did it. We did it again.